Welcome to the series of number system and conversion. This is our ongoing discussion on hexadecimal numbers, and the topic of today's discussion is convert from decimal to hexadecimal equivalent. So that means you are given a decimal number and you have to find out its hexadecimal equivalent. So let's get started. So this is the basic information which we must have while performing these calculations. Decimal number system is base 10 and hexadecimal is base 16, and these are the set of unique symbols each number system has. And you must also know the hexa equivalent of the first 16 symbols and their decimal equivalent. So for the symbols 0 to 9 in hexa, they are also equal to 0 to 9 in decimal. But the value A in hexa, that is equivalent to the value 10 in decimal number system, and value f in hexa is equivalent to the value 15 in decimal number system. So you must be familiar with these values. Now we will understand what are the rules of conversion, how to convert a fraction, how to convert a whole number, first without using calculator and then using the calculator. And this point we will come at the last. What it means we will see when we will solve some particular example. Now we are talking about fraction and the whole number. So the number that can be given to you can comprise of whole number. You can be asked to convert a fraction, and it can be also a mixed number, right? So our number can be made up of two parts, whole number part and fraction part. Now remember, there are different set of rules for converting the whole number to a hexadecimal equivalent and different set of rules for converting the fraction to the hexadecimal equivalent. For the whole number part, we use a repeated division by 16, and for fraction part we use repeated multiplication by 16. So in this case we will follow this repeated division by 16. In this example we will use repeated multiplication by 16, but when we get such a number, then we will use this method for 50 and we will use this method for 0.5, right? So two separate set of rules for handling the whole number part and for handling the fraction part. So let's understand them with examples. So I have this number 50.2815. So instead of converting this, let us split this number. First, we will learn how to convert this fraction portion into its equivalent uh, hexadecimal part. So given number is 0.28125. So I'll do the rough work over here. So this is my given number and we will multiply it with 16. Remember to put this fractional point over here, and this is what you get. So you have to just perform your simple calculation multiplication process. So this comes 5 and there one carry over there, and that will become 4, and this is our decimal point, right? So this number is now made up of two parts. We have the integer portion and then we have the fraction portion. So initial number was multiplied by 16, and we will write this like this. We will put one line in between. We will say multiplied by 16 and we'll put this answer. This integer sequence will be taken out separately and we'll put this decimal portion over here, fraction part over here. Now it is repeated multiplication by 16. So we will multiply this fractional portion again with 16. We will not take 4 into account. So multiplied by 16. So that will give me the answer 8.2. 0, 0, 0, 0, 0. That means if I multiply this number with 16, we get this. So this is 8 and this becomes 0.00. Now when I'm going to stop, this repeated multiplication has to stop somewhere. So we will stop over here once our this fractional portion gets all zeros, right? So just let's see this rule. What it says, successive multiplication by 16 and retain the integer sequence digit in sequence until the fraction is 0 or the number of digits required are obtained in case it is an infinite fraction. Then write the integer sequence from top to bottom. So this part is clear. First rule, successive multiplication, then you have to retain that integer sequence will give us that our equivalent hexa number, and we are going to multiply this fraction again and again by 16 till we get all zeros, or in case it is an infinite fraction, then we will stop after some number of places. Now what is the hexa equivalent of 4 is 4, hexa equivalent of 8 is 8. Now we have to write its this integer sequence will form our hexa. But how we are going to write? Are we going to read them from top to bottom or bottom to top? So what it's written? It is from top to bottom. So just put an arrow like this. This 4 will come over here and 8 will come over here. And don't forget to put this decimal point over here. So it becomes 0.48. Now in this example, if you see here, if I split this 0.28125 and by following that method, I get 0.48, right? So now you can see understand the rule. Successive multiplication by 16, we first multiplied the original number with 16. We split that number, we took out that integer sequence over on a side, and we are going to multiply that fractional portion again with 16. That is why it is successive multiplication. In this case, we stopped because this is 0. And you have to read all your remainder, this integer sequence from top to bottom, right? Uh, Before we complete this part, so here we are now, we know that this portion has to be calculated separately. But before I calculate this whole number 50, let me do one more example where this fraction is involved, right? 0.15. So 0.15 into 16. If I multiply it, this becomes 2.40. So it will be written like this, 2.40. Put a line in between so that you don't multiply that integer number. Only this fractional part has to be multiplied by 16. So 0.40 into 16, that will give you this 6.40. So this is our integer part. We will take it on this side, and this is our number 0.40. Now, if you multiply again with 16, this pattern is going to repeat. So you can just find your answer up till 3 decimal places. So 0.266. So the hexa equivalent of 2 is 2 and hexa equivalent of 6 is 6. So you can just leave your answer till 3 places, right? So this was an example of infinite fraction. Now let us understand how to convert a whole number to its hexadecimal equivalent. So in this number, because we had both the parts, so let us see how to work with hexadecimal, this whole number part. So we'll work over here. What it says, what are the rules for the integer portion? It says you have to divide the whole number by 16 and then repeatedly divide the quotient with 16 and so on. Let us see. Let's see with example. First, let me put it another way. This is my original number 50. I will divide it with 16. That is what this point says. And I'm not using the calculator, so I'm using manual calculation method, right? So this is my quotient and this is my remainder. So we can arrange this like this. Instead of writing so many division steps like this, we can arrange it like this. We will write the number over here, 50, and our divisor is 16. 16 into 3, we will write the quotient part over here and the remainder part over here. So this will accumulate all the remainders. Now, till when should I, again, this is what? This is repeated division. So till when should I divide? I will divide the quotient with 16 again till this quotient part becomes 0. So we will again divide like this, 16 divided by 3. Okay, so 16, remainder will be, this quotient will be 0 and remainder will be 3. Now, how I'm going to write these, how I'm going to convert this remainder into a hexa number. See, these remainders will form our hexadecimal number. Now, for the decimal, hexa equivalent of 2 is 2 and hexa equivalent of 3 is 3. And now we are going to read in reverse direction from bottom to top, bottom to top. And it will come like this, that is 32. So this will become your least significant digit, very first remainder, and this will be your most significant hexadecimal digit. So we have to write in this direction, right? So I was not using any calculator over here, so just let me copy paste and let's see where does the difference lies uh, in the fraction part and in the whole number calculation. So this is the fraction part, or sorry, whole number part, and let us bring this from here, 0.28125. So you can see this. You can now get the difference. 50, right? So 50 is solved over here, and this 0.28125 is solved using this method, right? And you can see for yourself that there is the procedure for finding the hexa equivalent of the decimal portion and of for the whole number part and fraction part are different. Here you are doing repeated division and here you are doing repeated multiplication. But when it's a mixed number, so you can be only given 50 or you can be only given 0.28125 or it can be a mixed number. But then how will you write? In this case, how will you write the final answer? This will become 32.48. So you are reading in reverse directions. Remainders will form the hexa number. So you read in reverse direction from bottom to top. In this case, you are reading from top to bottom, and that integer sequence is going to give you that hexa number. So let us do some more practice. 50. We have already done this. 255. So what will come for 255? We know that its decimal equivalent is hexa equivalent is FF. Let's see in our calculator first. We will go for programmer calculator, and this is my decimal calculator, and I'll say 255, and my hexa quantity is double F. So let's see whether we get the same answer or not. So it is repeated division. So first we will divide the original number with 16. And we will write the remainders on this side. So 255 divided by 16. So this becomes 16 into 5 is 80 and you are left with remainder 50, right? So we will write the quotient part over here, 50. And write the remainder part over here, 1 5. Now we will continue dividing till we reach 0. So 16 divided by 15, so this will become 0, and this 15 will become the remainder. So here we will stop, and we will read from bottom to top. But first I need to convert them into their hexaequivalent. So this is F and this is also F. So answer will be F, F. So let me write in separate colors so that you can know where I have written which number. So this is your least significant hexadecimal digit. This becomes your most significant hexadecimal digit, right? So up till here, we were not using calculator. But let us solve this value 50 using calculator, this one. We solve this entire thing uh, by not using calculator. But let us see what happens. So here we will revisit this point. It says that when quotient has a fraction part, either using calculator or otherwise, then a rule will be slightly different. So what is the rule? Let us see that. It says when quotient has a fraction part, the fractional part is multiplied by the divisor 16 to get the remainder. Sometimes when we use calculator, then quotient part will be generally given with a fraction. But sometimes when we are, even if we are doing manual calculation, our quotient will have a fractional part. So let us see both the cases. We'll solve this question again, but this time we will use calculator. Okay, 50. So we'll do that over here. 50, this is a decimal number. You have to find out its hexadecimal equivalent, and we are going to use calculator. So how we will write? We'll write 50 divided by 16, right? So let us see what comes. So we can use our scientific calculator. We have 50 and that is divided by 16. So we get the answer 3.125. 3.125. Now this 3 will be treated separately and this 0.125 will have a separate treatment. How to go for that? Let's see. We will first consider this integer quotient. That is our quotient. So it is like this. When you write 50 divided by 16 and you continue doing that, this is what you are going to get. Okay. So we will consider this first, the quotient, whole number part of our quotient, and we will divide it again with 16. So it is for the whole number quotient part, it will be repeated division by 16 till we get 0. So 3 divided by 16, let's see what answer we get. 3 divided by 16. We are getting the answer 0.1875. So we get 0.1875. And now we have reached 0. Our integer quotient part has now become 0. So we will stop over here. But how to find out those remainders, right? So we will now treat this fraction part. So how many fractions we have obtained? 2. We will multiply each of the fraction with 16. So 0.125 into 16 and 0.1875 into 16. So 0.125. You can just multiply it over here. 0.125 and that is multiplied by 16. It's giving me the answer 2. So that is equal to 2. Now 0.1875, and that is to be multiplied again by 60. You get the answer 3. So what I did, this fractional part will be multiplied by 16 to obtain this remainder. So this will now form your remainder. Had it been 11 or 13, then I would have converted it into its hexadecimal equivalent, but hexa equivalent of 2 is 2, hexa equivalent of 3 is 3. Now read these remainders from again from bottom to top and see what answer you get. 32 in hexa. Let's check it with this number. We did this without using calculator and we got this answer 32 in hexa, and same number we are getting, but this time we were using calculator. So only difference comes that this quotient will be now made up of whole number part and fraction part. You have to continuously divide that whole number quotient part with 16 till you get 0. And for the remainder portion, just multiply each of this fractional part with 16, that is the divisor 16, or you can remember base 16, and you will get the remainders. And just convert those remainders into their hexa equivalent and you will get this answer. So I was using calculator in this case. Now let us take this example first, 650, right? What is 650 equivalent to? So 650. We will try it with first manual division. Okay. I say this is basically a decimal number. Try to find out its hexadecimal equivalent. So 650. Even if I go for manual calculation, it will give me fractional quotient. Why? 16 for the 64. If I start calculating in this way, I'll have to at least put 1 0 over here and 0 and then point, and then I'll have to continue my calculation further, and you will see that this quotient will become I will have a fraction part. So 16 into 6 is 96, and I'll keep on moving like this. But then I'll have the difficulty in obtaining the remainders. So even if I'm doing manual calculation, my quotient is ending up with a fractional portion in it. So and I'll start using the calculator. When you use calculator, then quotient part will be generally having whole number part as well as the fractional part. So I'll write 650. This is my original number. I will divide it with 16. So what I get? 650. Sorry, I went wrong. It is 650, and that is to be divided by 16. And what I'm getting? 40.625. So that is equal to 40.625. I'm just changing the color to let you know that this is, so that is what you get when you say 650 divided by 16 and you get this 40.625. This is the quotient. So this is the whole number part and this is the fractional part. So separate treatment for this portion. Now we will again divide 40 with 16. So first finish up with this whole number quotient, and then when you get 0 in this in this position, then you start working out with these fractional quotient part. Okay, so 40 divided by 60, that will give you 40, 2.5. So we are getting the answer 2.5. Now we will again bring 2 down because our quotient whole number quotient part hasn't got 0 yet. So this will now become 2 divided by 16. So you just do that over here. 2 divided by 16, and you will get the answer 0.125. 0.125. Now I have got 0 over here. My integer quotient part has become 0, so I will stop over here. Okay, but what to do next? Now I will start working with this portion. I'll work with these numbers now. So what I have to do this with this fractional quotient part, we will multiply each quotient with 16. 0.625 into 16, zero point 0.5 into 16, 0.125 into 16. Whatever answer you get will be the your remainder. So 0.625. So let's clear this out. 0.625 into 16, and that is the answer you get 10. 0.5 into 16, and you get the answer 8. 0.125 into 16, 0.125 multiplied by 16, that will give you the answer 2, right? Now these are your, this set will form the remainders, but we have to write their hexaequivalent. For 10 it is A, for 8 we know it will remain 8, for 2 it will remain 2. Now as we did in the previous case of whole numbers, we will read all these remainders from bottom to top, and our answer will become 2. We'll write in this direction 8A. So A will be our least significant hexadecimal digit, and 2 will be most significant hexadecimal digit. Whichever first remainder is there, that is the least significant digit. So this is our hexa number. Let us see if I get the same answer. So just we will switch over to our programmer calculator, and let's see 6, 5. Let me first write this hexa equivalent 6, 5, 0, and something has gone wrong. Wait, I'll write this decimal number 650, and see its hexa equivalent is 28A. So that is what you got. So what we did, now we will just go through those rules, right? For the fraction portion, it was successive multiplication by 16. We will retain the integer sequence, digit in sequence, until the fraction part gets 0. A number of digits required are obtained if it is infinite fraction. Then write all the integer sequence, that is their hexa equivalent, from top to bottom. And for the whole number portion, it was divide the whole number by 16, repeatedly divide the quotient with 16 till integer quotient gets 0, write the hex equivalent of remainders, and write the remainders from bottom to top. So when quotient has got a fractional part, the fractional part is multiplied by 16, that is the divisor 16, to get the remainder. And when a quotient part will have the fractional part, whenever we are using the calculator, or even the manual calculation, will yield a, or will give a fraction quotient with the whole number part as well as a fractional part. So we will just see all the examples one by one. Last, this was our 0.15, so that is repeated multiplication by 16, and this is again repeated multiplication by 16, and this is our whole number part, right? Here when you get 0, you will stop, and this is again our whole number calculation. Here we have solved the 50 using calculator. Here we have used 650 using calculator. Now you can try out this value yourself, 651, using calculator. And in case of mixed numbers, you see here, we will solve this whole number part separately and this fraction part separately, and then we will combine the result. So having said that, you can practice out some more examples, and I will see you in my next video. You can listen to the video, that is convert a hexadecimal number to decimal equivalent. I've given that link in my description box. You can also check my playlist for the rest of the videos on the hexadecimal numbers. And one more video is coming up, that is counting in hexadecimal numbers. So till then, thank you, take care, bye bye, and see you in my next video. In case you have understood, you can subscribe, like, and share it with your friends.